Hi there. This is a recording of a presentation that I gave for the DevOps meetup in Melbourne on the 24th of November in 2015. This presentation is about preparing deployable code using Docker and Jenkins. Before we get into the cool part, let's talk for a moment about who am I? Well, my name is Arjen Svalts and I am Dutch. Back in the Netherlands, I used to work at a traditional hosting company doing development and some ops work as well. But then at some point I decided to go traveling and traveled around the world a bit until one day I arrived in a city called Melbourne and I really enjoyed it here. So I decided to stick around for a bit and I started to work at a digital agency where I once again did a lot of development and operations work. The interesting bit then. When I talk about preparing deployable code, what do I mean by that? After all, shouldn't the code already be ready to deploy? That's why after all you build it in the first place. Well, as it happens, things have become a bit more complicated. Where in the past, if you were to build a web application, it would be maybe some hacked together PHP scripts and that together with some basic HTML table driven UI. Nowadays it's just a little bit different, as a lot of clients, where clients can mean either external or internal clients, they will already have existing data centers, or they host their servers in the cloud, or they want self-healing and tiered scalable applications. But that's not all. It's also on the code side, a lot has changed, where still PHP is a big player, but it's not just PHP. It's Ruby, other languages like Go or Java or anything. And all of these languages have their own dependencies, their own requirements. The same goes for the front-end applications. Developers are no longer just building straight CSS and JavaScript. They compile and build upon what other people have done, using either building frameworks like Grunt or Gulp or whatever the JavaScript framework of the week is. Or they go even further and they use complete application frameworks like Ember or Angular or React. And basically all of these have generated code or third-party code, depending on what it is and how it's used. So we have to deal with that in some ways, which is a problem when it comes to the deployment. Well, we have our deployments, of course, set up to be automated. We have our scripts, whether that is run from the command line or if there's fancy UI for it. Basically, you want everything to be automated. But when it comes to generating this code, it's not always good for the servers it runs on. Just running npm install can take up to 100% of your CPU. Basically, it just grabs everything it can get its hands on. And that's just not really something you want to run on your servers. Aside from that, your servers have requirements for all of these things. You might need a specific node version or a specific version of SAS or ImageMin. And it can differ per project because you are dealing with projects that might have been started 5 years ago and not have had updates since then. They will have a completely different setup and requirements than a new project that you started last month, simply because the technology moves so fast and therefore new stuff comes out all the time. And most importantly there is that this will run on production servers. You don't really want to run all these things on production servers. Not only do you not want to deal with the CPU usage that I just mentioned that will interfere with the way your site will be reachable, but also things fail, and it doesn't have to be your own fault. It can be that an NPM server is unreachable, as has happened to me in the past, where deployments failed because NPM in Australia was unreachable. It can be anything else. Anything that is out of your control. But what then? Well, can't run it on the production server. Maybe then just commit generated code? But that's not really what you want either. This tends to lead to issues. You get a lot of conflicts when you commit generated code, and your developers will not be happy to deal with that. So that really brings you to the definition of the problem: asset compilation. We want to compile these assets, but we don't want to do it on the production server, or let our developers do it and push it up. So where do we do it instead? Now, there is a step in between these two, which is continuous integration. Continuous integration, for those of you not quite familiar with it, is basically a way of running commands on your committed code. This can be lin checks, unit tests, code style checks, documentation, anything you want. Now, in my example, and as part of the title for this presentation, is Jenkins. That is one of these continuous integration tools. Whether or not you will actually use that one, whether or not you actually use Jenkins, doesn't matter here. Anything I say should be usable by other CI tools as well. I'm mostly just using Jenkins because I'm familiar with it and we set it up with that. Now, the idea is to compile it once and then deploy it everywhere. So, how would we go about that? Let's go through the process. We push our code up. Jenkins then says, hey, there's new code. It picks it up and starts running its tasks. First, it runs a lin check, and then it runs the unit test. If this was just limited to this, they could then put up a flag and say, hey, this code is good, let's deploy it. But we wanted it to do more. We also wanted to run npm install, do a grunt build, all of these things that are required to compile the assets that we need. In Jenkins, this is quite easy to set up. You manage your project with an end file called build.xml, where you can just add a target. In this case, it's a grunt build, which just runs grunt with the argument build. That will then just run the same things you would usually do. But then what? We've now got this code locally on our continuous integration machine, but that's not where we want to end up. We need it on our production machines or on our staging machines or whatever. So how about we just commit it to the repository? Yeah, I know, I just said we shouldn't do that. But I'm not talking about committing it to branches that people actually work on. No, instead, we can push it up to release branches. If you're familiar with something like Git Flow, then you're most likely familiar with the term of release branches, or the idea behind them at least. These release branches are special branches that you will use to do your deployment from. Instead of deploying straight from your master branch, you would create a release branch, tag it, and you do the deployment from there. Again, in Jenkins, that you can just, after doing everything, you can tell it to push up to a different branch. This way I've got it set up would be to push it up to a release/branch name branch. So in this case, release/staging. Alternatively, you could package it. Just zip it up and, for example, push it up to an S3 bucket. This especially works quite well when it comes to autoscaling servers. As part of your deployment, you just kill off the servers, and when the new ones spin up, they will just pull in this latest code, and then you've got the latest code running on those servers. Now, what does this mean in that same schema I just showed you? Well, you still have your run npm install, do your grunt build, but then you commit the code or zip it, and then depending on which one you chose, you push it to the repository or you push it to an S3 bucket, and from there you just do your normal, regular deployment setup. All done, great, everybody's happy. Except we're not done yet, because as it turns out, while this is definitely a big improvement, it doesn't solve all the problems. The main problem we still have is that of the server management, or rather dependency management. If you have different versions, as we've mentioned before, that your projects will have, you can't really handle those easily on a single server. In Jenkins, you can set up slaves, and you could then have specific servers configured for specific setups. But this doesn't work well, this doesn't scale, because you still have to manage all of these servers. Besides, even if you didn't, you end up with some servers being used a lot, other servers just being idle, and it's just a waste of your resources as well. So this just gives you a new version of the dependency nightmare that I mentioned earlier, because not only will you have to deal with those different PHP versions, you also have to deal with different versions of Node, NPM, SAS, all the things I mentioned before. So, how do we solve this? Well, and to Docker. For those of you not familiar with Docker, Docker is awesome. It's great. It's the future, the solution to all our problems. Or maybe it's just a container management system. And what it allows you to do is build these lightweight containers. And these containers run a lightweight OS, basically intended for a single task. They also only take up milliseconds to seconds to start up, which makes them much more useful than a VM in this case. Additionally, you don't have to log into them to run something, but when you start them up, you do it specifically with a command. So, how would we use these containers? Typically, Docker is often used in projects by providing a Docker file, which is basically the configuration file of what needs to go into the container, and then basically bake the project into that container, and then you can deploy that container to your testing service, staging, production, but that's not what we need here. No, instead, what we can do is build task-specific containers. These containers will be aimed at doing single tasks, or rather, single kind of tasks. So, what that would mean is, if we look at these 4 steps again, we could run each of these on a container. PHP container for the lint and unit test, and node containers for npm or grunt. Now, let me use an example to clarify this a bit. Say we have a legacy site. It runs on PHP 5.3 on load balance servers that are managed by the client. But not that long ago, the most important part of this site was actually replaced with a fancy new Ember application. So, how would we optimize the asset compilation here? We start with a PHP 5.3 container. This will run the lint checks, the unit tests, things like that. But when it comes to things like the style checks and documentation generation, we can instead use PHP 5.6 for that, because it's faster, and as that is not something that actually matters on the production servers that the site will run on, because they don't care if our code follows our style guide. We can run that on 5.6. It's faster and works just as well. And the Ember build itself, for the new part of the site, we can run that in an Ember container. Of course, we can go even fancier with this and run the same tasks for the lint and PHP unit on a PHP 7 box, just to future-proof it. Or if we want to be less pie in the sky, we could do that for PHP 5.6 in case the client decides to update the servers. That way we know without a lot of work that everything is future-proofed, or not, in which case we know what to fix. Now, when it comes to changing it to the build.xml file in this case, it obviously has to change a bit. So instead of this nice small command, what we have to do is use Docker to run all the commands. It's actually a little bit more complex even still than shown here, but for readability I left out some parameters for the grunt build process. Basically, you run Docker, you mount the current directory as a volume, and then run the grunt build on that container. Now, the issues with this that I'm not going to go into too deeply here are that Docker generally runs as the root user. Grunt, npm, all those tools, they don't like that. So you have to add special arguments to the commands to make that work. Additionally, because Docker runs as root, all files generated by it will also be owned by root. So you might need to have a cleanup script, because otherwise Jenkins will complain about that. Now, the big advantage of this is that you end up with everything on a single server. All of these containers we can share across the projects. You can use the same PHP 5.6 container for all your projects. You can use the same node container for all your projects. Or if you need different versions of these things, you can version these containers as well. Just give them a tag, and then run the different versions of it, which means that the server itself is simple. You only need Jenkins on it, and of course Docker. But other than that, it's lightweight and less prone to failure. So, thank you for watching. You can find my site on Ignore Me, or if you want to reach me over Twitter or see my work on GitHub, just use Arjen's Thoughts. And I hope you enjoyed this. Thank you very much.